Hi guys, today's video is our first lesson in our 7th chapter. I think you'll find today's chapter fairly easy. It's a lot of like classification and being able to talk about different math things. And then some of the math that we're going to do, we've already done this year. So hopefully today is a piece of cake for you. It does revolve around polynomials. So let's discuss what a polynomial is. It's an expression consisting of many terms. So an expression consisting of many terms. And you might be like, well, what the heck is a term? So let me write a few examples here. So an example could be like 5, but it could also be something like 6x or 2x squared plus 1. Or maybe it's 9x cubed plus 4x squared minus x minus 2. It doesn't matter. Those are all polynomials. These are examples of having one term, whereas 2x squared plus 1 has 2 terms. This last example here has 4 terms. So a term is simply like those things on this, like either side of your addition or subtraction. So however many there are the number of terms. For something to be written in standard form, it must be written in alphabetical order and with the highest exponent. So with the highest, or maybe you think about that as the largest exponent first. So, and it should just go like down in descending order. So it must be written in alphabetical order and with the highest or largest exponent first. So our first set of examples here say, write each polynomial in standard form. So the first thing you're going to want to check is, well, for one, what letters are there? So in this first example here, there's only x's. And then we'll find our highest degree term. So this term has an x. This doesn't have a letter even with it. And this is an x squared. So this is my highest exponent. So the 2x squared would come first. Then the 3x, because that's like to the first power. And then plus 1, because that's essentially, it has no x. It's like x to the 0 power. So this here is in standard form. All right, let's try another one. So we have k squared plus 64 minus k plus 7k cubed. So it's all cubed, so we're good. Or k, sorry, no other letters are involved. I have a k squared, I have a k, and I have a k cubed. So k cubed is definitely the highest. So 7k cubed would go first. After that would be the k squared, then minus k, and then the one without any k, so plus 64. So it's like the letter slowly goes away. All right, I would like you to try number 3 on your own. So go ahead and put that in standard form for me. All right, then we're going to do 5 together. So it says 2ab plus a cubed plus 5a squared b squared minus 2b cubed. So again, it should be written in alphabetical order. So the a has to come before that b. So with the a's, a cubed is the only one that's all by itself. So a cubed is going to come first. So I use this one. Then I have an a and a b and an a to the second and a b to the second. So this is bigger than my ab. So I'm going to write plus 5a to the second, b to the second next. Then I have 2ab. And then lastly would be this b cubed all by itself. So to write it in alphabetical order, anything that has an a first has to come before anything with a b. So that's why the b cubed, even though this power is really big, it's a b. So a obviously comes before b. So it still has to come at the very end. All right, I would like you to try number 6 on your own. So you do have C's but you also have D's. And then since this doesn't have a letter, it'll just go on the end, just so you know. So again, put it in alphabetical order with the largest C's first, and then the D has to go all by itself at the end. So go ahead and try number 6 on your own. All right, for number 7, it says polynomials are classified by their degree and number of terms. So if the degree is 0, it's called a constant. So an example of that would just be any number, so like the number 5. If the degree is 1, that means it is linear. So an example of that would be if it said something like 5x, because the degree here is like a 1. Next is a degree of 2. We call that a quadratic. So when the degree is what's on the exponent. You might want to add that up there. A degree is the exponent. So it's on the variable, it is the exponent, I guess I should have said. So an example of that could be like 5x squared. This 2 here makes it a quadratic. If it has a 3 as an exponent, we call it a cubic function. So an example of that could be like 5x cubed, again because of that 3. And lastly, if it has a 4 on it, we call it a quartic function. An example of that could be 5x to the 4th. Again, we're looking at that exponent on that variable. As far as number of terms in a polynomial go, if it has 1 term, we call it a monomial. So an example of a monomial could be like 5x. If it has 2 terms, we call it a binomial. So something like 5x plus 2 is a binomial. There's 2 terms. If it has 3 terms, we call it a trinomial. So that could be like x squared plus 5x plus 2. That has 3 terms. If it has 4 or more terms, we call it a polynomial. Let me spell that right. Polynomial. And an example of that could be like x to the 5th plus 4x to the 4th plus 2x squared plus 3x plus 5. Something like that is a polynomial. Anything with 4 or more terms. So this next set says classify each polynomial by a degree and the number of terms. So it's just the number 6. So do not hesitate to go back up here and look at your rules. It's just a constant number, right? There isn't a letter with it. Whoopsie daisies. Thought that was the highlighter. Since there isn't an x there, we call this thing a constant. And since there's only one thing listed, there isn't stuff being added or subtracted to it, it would be a monomial. There's just one term there. So go ahead and try number 8. I'll give you a hint. Use like my examples up there to help you. So number 8 says negative 2x. For number 9, it says 7p plus 1. So if we look at our exponent here, that's like a p to the first power. So if you look at your list, if it has a degree of 1, it makes it linear. And since there's 2 terms here, 1, 2, 2 terms means it's a binomial. All right, with number 10, I have v squared plus 2v minus 5. There's 1, 2, 3 terms, which makes this thing a trinomial. If you look for your highest degree, it's a 2 because this is like a 1. So then go to your degree column, what do we call it if it has a degree of 2? And it's a quadratic function. So this one is quadratic and a trinomial. All right, go ahead and try number 11 on your own. So you're counting the number of terms and then the highest degree and name it. Now try number 12. Count your number of terms, look for your highest degree on your exponent, and classify it accordingly. All right, Last little bit here is really like combining like terms. So to add and subtract polynomials, you simply have to combine like terms. You just have to be pretty careful with the subtracting. The adding's not terrible. So in my example here, I have 11x minus x squared plus 13 plus 2x squared minus 23 minus 5x. And you're simply going to combine like terms. So I have an 11x and a minus 5x. So I'll combine those. I have a negative x squared and a 2x squared. I have a positive 13 and a minus 23. I just have to write these in standard form, which means I have to put the highest exponent first. So I'm going to look at these x squareds first. So I have a negative x squared and a positive 2x squared. So 2 minus that 1 means I just have an x squared. I have an 11x minus 5x. That makes 6x. And I have 13 minus 23, which makes 10. And that would be your answer. For subtraction, I truly suggest distributing this negative and then adding them. It'll make it so you don't make a stupid sign mistake. So I'm going to rewrite this first binomial, 4x squared plus 5x. Distribute that minus. You get minus 7x minus 3x squared and a minus 1. Now simply combine like terms. So I have a 4x squared minus 3x squared. So 4 minus 3 makes an x squared. Then I have a positive 5x minus 7x. So 5 minus 7 is a negative 2x. And then this minus 1 doesn't have anything to combine with. So that's just my answer, x squared minus 2x minus 1. All right, go ahead and try number 13 on your own. So you're doing x plus 5 plus 4x minus 7. All right, I'm going to go ahead and do 14 with you. So it is just being added again. So I'm going to look for like terms, starting with my highest degree. So I have a k squared and a k squared. 1k squared and 1k squared makes 2k squared. Then I have a negative 4k plus 9k. So negative 4 plus 9 is a positive 5k. Then I have a plus 7 and a minus 3. So 7 minus 3 makes 4. And that would be your answer. All right, go ahead and try number 15 on your own. All right, for number 16, it says 9x minus 5y plus 3x plus 2y minus 7. So remember, to put this thing in standard form, I have to put it in alphabetical order. So x comes before y. So I have a 9x and a 3x. That makes 12x. I have a negative 5y and a positive 2y. So that makes a negative 3y. And then I just have this minus 7, so there's nothing to combine it with, so I'm just going to put minus 7, and that would be your answer. All right, I'm going to jump down to number 19. So x squared plus 17x minus 3x squared plus 5x. So like I said earlier, I recommend distributing this minus sign in, otherwise you oftentimes run into like negative troubles. Sign mistakes. So this would make this a negative 3x squared and a minus 5x. So now I can combine like terms. I have a 1x squared minus a 3x squared. So that makes minus 2x squared. Then I have a positive 17x minus 5x makes a positive 12x. And that would be your answer. All right, go ahead and try number 20 on your own. So you're doing 5r minus 2s minus, and again, I would rewrite this thing, distributing the subtraction sign in there. So remember, a negative will turn a positive negative, but distributing a negative to a negative will make it positive. So when you distribute that, you should get negative 9r plus 11s. All right, go ahead and combine like terms. Okay, I'm going to do number 22 with you. It is subtraction again, so I am going to distribute this subtraction sign in. I'm going to rewrite my first polynomial, or I should say trinomial, distribute my subtraction, so that become a minus m squared minus 2m, and my negative times my negative will make that a positive 5. So now I can combine like terms. 3m squared minus a 1m squared makes 2m squared. A 7m minus a 2m makes 5m. And I have a negative 1 and a positive 5, which makes a positive 4. And that would be your answer. All right, go ahead and try number 24 on your own. All right, that concludes your video on classifying polynomials and adding and subtracting them. If you have any questions, let us know.